did with angles yesterday. Yesterday was really setting the foundation of being able to name angles appropriately, as well as talking about the measurements of them. A lot of what we did yesterday is things that you have technically done before. Today, shifting a little bit to talking about things that you can do with angles. Now, the first thing we're talking about is the angle addition postulate. Now, the angle addition postulate is just a fancy word name for something that you probably instinctively have an idea of how to do. Because if I told you that this angle right here was 40 degrees, and that this angle right here was 60 degrees, what would you tell me the big angle is?
100.
100. You just used the angle addition postulate. The angle addition postulate just says that if you have a situation here where you've got two angles right next to one another sharing that middle ray, we call them adjacent, by the way, when they look like that. If you have a pair of adjacent angles, you can add them up to make the larger angle. This is the formula for that. Measure of angle DEF plus the measure of angle FEG is equal to the measure of angle DEG. Now, I should have mentioned this as well. One thing that can also help with these problems, and it's up to you on if you feel this is going to be helpful for you. It's one thing that people often do with angle addition postulate is they use highlighters to kind of help them see what's what. They use different colored highlighters. I have different colored highlighters up here. If you want to grab 3 different colored highlighters, go for it. I'm going to pause. If you want to grab highlighters, go on. Still in packaging. Yeah. Sorry. Oh, sorry. So, it really just comes down to the 2 small angles add together to make the big one. This is the angle version of part plus part equals whole, which we did with segments. Now, sometimes when they do this, people are highlighting. I'm going to pause for half a second, give people a chance to get caught up with me. You don't have to highlight this too. If it's easier for you to read this version of that, it's the same thing. The way I did it, the green part plus the yellow part add up to the red part. Okay. So, when coming across problems like this, sometimes they are going to look like this here, where they already have the labels on the picture for you. Now, we are looking to find angle MKN. That's what it says we want to find. Is angle MKN the left half part, the right part, or the full thing? It's the right part. So that's what we're looking for the measure of. Now, we know it as 4x minus 3. You cannot tell me that the answer is 4x minus 3. That's not how it works. When I ask you for the measure of an angle, I'm looking for it as a singular number. So, my angle addition postulate says that I can add those 2 things together if I want. First one, if I go by names first, is angle LKM. Plus, the second one we just established was angle MKN. And when I add those together, I should get the full angle. The name of the big angle being, what? What's the big angle's name? LKN. Now, I write this out, where that's my green part, this is my orange part, and then I'll make the big one red for mine. I write that out not because you have to at this point, but because there's going to be a point where you do have to write that out. Just like segment addition postulate, there's going to be a certain point where we do have to write that out, and it's coming up in chapter 2. Do I know the measure of angle LKN? It's not drawn on the picture. It's impossible to draw that on a picture nicely. But do they tell it to me in the words? Yes. So on these problems, you're often going to have to mix together what you know from words and what you know from the picture. LKM, the green one, was 2x plus 10. Now, do you notice that it's got parentheses around it? But, do you notice what's outside of the parentheses? The degree symbol. And that's true for the 4x minus 3 as well. If the only thing outside of the parentheses is the degree symbol, then that is the only purpose of the parentheses, is to hold on to the unit. When you write equations, do you typically put the units inside of the equations? No, you put units on at the end generally. So, when you're writing these equations, you do not need the parentheses unless there's something outside the parentheses other than the degree symbol. So when I go to replace LKM and substitute in what it's equal to, the 2x plus 10, I'm not going to use the parentheses. That came from that. Add MKN. What's the expression for that? That's the 4x minus 3. Equal to. LKN is the full thing. And the full thing we said had a measure of 145 degrees. Now, on that quiz, I was seeing some algebra things. So with some of the algebra, I'm going to slow down a little bit today. Remind us of some of our things that tend to trip us up. Specifically, multiple variables in the problems, or multiple x's, I should say, because it's the same variable. When you see x's in multiple places on the problem, you must ask yourself, are they on the same side of the equal sign, or are they on opposite sides? Same or opposite for these two? Same side. When they are on the same side of the equal sign, you do what the problem says. You just focus in on them and read it across. If I focus in on them, it says to take 2x, ignore, and add 4x. Do not do opposite operations. Too many people on the quiz did opposite operations. Opposite operations moves things to the opposite side of the equal sign. They're on the same side. I don't need to do anything opposite about them. 2x plus 4x. 6x. I do the same thing with my regular numbers. These ones are on the same side. If they're on the same side, I do exactly what they say, and they say to take 10 and minus 3 from it. 10 minus 3 is positive 7, equal to 145. Now, once people got to this point, for the most part, they did fine. Occasionally had some issues with positives and negatives, but that wasn't consistent. They just made a little error. So, minus 7, 6x is equal to 138. Divide by 6, and x is equal to 23. Yep. Thank you. The next mistake that I saw a lot of people doing is they would stop right there, regardless of what the question said it wanted. What did this question ask me to find? The measure of angle MKN. Now, MKN was orange, and orange was 4x minus 3. Now, once you know what x is, you're plugging it in. Some people had issues plugging it in. That was another common mistake I saw. When you're plugging something in, it's also known as substitution, by the way. You are finding what that item is equal to. X is equal to 23. And you're replacing that item with the number in the expression, in parentheses, and only that number has parentheses around it. So when I write 4x minus 3, it's 4 and parentheses around a 23, which I have to close before I do minus 3. From here, it's order of operations. Now, if you have issues with order of operations, I will tell you right now, your calculator doesn't. Your calculator knows order of operations. Especially when it's this type of order of operations. You can type that entire thing into your calculator, provided you have a scientific calculator. If you have one of the, where did it go? I used to have one of the non-scientific. If you have an itty-bitty calculator that doesn't let you type in more than one thing, that becomes a problem. But if you got one that's, it doesn't have to be a graphing calculator, it can be like my little ones, provided that when you type into it, if it lets you see this entire thing on screen when you type it in, it will know exactly what to do with it. I don't care if you're using your calculator for this stuff. I'm not expecting you to do it in your head. I expect you to know how to type it in. And if you know how to type it in, then you're golden. Because how often in life do you not have a calculator with you?
Pretty often.
You don't have your phone on you very often?
Oh. Yeah.
Phone is a calculator. Now I'm going to tell you this right now. Your calculator on your phone, does it allow you to type this entire thing and still see it all on screen?
Yes.
Most do not, unless you get a specific scientific one. So there's a little bit of give and take on that fact. You could get a scientific calculator on your phone. Like I have a graphing calculator on my phone.
Calculator has an option to turn it scientific.
You do. Okay, measure of angle MKN is therefore equal to 89 degrees. I do not get overly finicky if you put the degree symbol on for angles. I do get finicky that I see this. Measure of the angle's name. Okay. Sometimes you're going to have the problems like that where they draw the picture on with the expressions right on it. Honestly, more often than not, they're just going to list it out in the words. Here's where my highlighters become hugely helpful. I want to find the measure of angle SRD if SRQ is 175. Here's S, here's R, here's Q. From R going out towards Q, going out towards S, that's the big angle. SRD is x plus 30. There's S, there's R, there's D. R is the vertex going towards R, going towards S. That's that one. That's also what we were looking to find. DRQ, there's R, there's D, there's Q, that's that one. Now, Some people at this point go directly to writing out their equation. Some people write out the wordy version. I'm going to start with the wordy version. Measure of angle. Which two angles am I adding together? Go by colors. Am I adding together red, green, or orange? Red and green are my two small ones the way I have it drawn. The red one's name was SRD plus the green one's name was DRQ. Add those together and you get the orange one, which was measure angle SRQ. Do you have to write this every single time?
Yeah.
No. Will you see me write it every single time? Yeah. What I expect many of you to go to is going directly to the expressions, and I'm okay with that. But this helps me make sure I get the right expressions. The other way you can make sure you get the right expressions is to draw them directly on the picture to help you out. That's the x plus 30. This is the x plus 155. There's not a great way to put the big one on there. Some people do this. They kind of make a rainbow thing going on and say, hey, that's 175. You don't have to do that either. I recommend you either label your picture or you write out this equation. This we're going to eventually have to do, so it's not bad to get practice at it. SRD was the red one, x plus 30. Plus DRQ was the green one, x plus 155. SRQ was the orange one, 175. And if you want to highlight this equation as you go through too to help you keep track of things, go for it. The different color highlighters can help you keep track of what's what. Okay. Trying to solve. How do I put the x's together? Do I do x plus x or do I subtract x from both of them? They're on the same side. X plus x, 2x. 30, 155, and 175 are all plain numbers, but 30 and 155 are on the same side. Positive 30 plus 155, 185. At this point, people generally do fine with solving. So for the sake of time, I'm going to tell you x is negative 5. Am I done with the problem?
No.
No. What did it say to find?
Find SRD.
What is the expression for SRD? X plus 30. I know x to be negative 5. So I replace the x with negative 5 and parentheses directly around the negative 5. Now, as I do this, are these parentheses actually doing anything? Not on this one. So I can go negative 5 plus 30 and I get 25. Go ahead and flip to the next page. On this problem, we're not going to do the entire thing. For the sake of time, we're just going to talk about labeling it, and then the last two are a little bit different.
Today, what you have?
I'm never going to answer that in the middle of the lesson. Okay, measure of angle BCY. I want to know where that is on the picture. Is that on the left side, the right side, or is it the full thing? It's the right side. C is the vertex, goes towards B, goes towards Y. And if you want, as you do this, I could call that 9x minus 3. YCD. Left side or full thing? C's in the middle, goes towards Y, goes towards D. Yes, left side. 82. Which means BCD, I hope, is the full thing, is it?
Yeah.
Yep, C in the middle, go towards B, go towards D. All the way across is the 18x minus the 2. Which 2 would I be adding together on this picture? I was told BCY, so green and red? It's the 2 small ones you add.
Hold on.
Green and orange.
I need to go.
Okay. Obviously, there would be more that we do on that problem, but for the sake of time, like I said, we're going to pause on that problem. Last 2 problems are similar, but a little bit different. What's the big difference you notice about the last 2?
They don't give you a graph.
They do not give you that picture. Yesterday, I talked about this idea of interior points and exterior points. In this picture, we are told that T is in the interior of angle HIJ. That means I've got an angle HIJ. So what I'm going to do is I'm going to draw myself an angle. And I'm going to call it HIJ. Now, if it is HIJ, the vertex is I. H and J need to go on each side. Doesn't matter which one puts the H and which one gets the J. You just got to know. And it says T is in the interior. Interior means inside. Between the 2 rays somewhere. There's T. Now, as it does this problem, it starts talking about angles that involve the name T, that involve the letter T, which means it wants me to do this with it. From there, everything's kind of following the same idea. Find the measure of angle TIJ. Is TIJ the tiny one, the medium one, or the big one? Medium. I in the middle goes towards T, goes towards J. That's what we're looking for. We are also told down here, by the way, that TIJ is 8x minus 4. We are told that measure of angle HIT is 18x minus 1. HIT, is that the little angle or the big one? I is the vertex, go towards H, go towards T. There's the little one. 18x minus 1. And then measure of angle HIJ is 177. Is that the big one? I is the vertex, go towards H, go towards J. Yes, that is the big one. If you want to do the little rainbow thing and call that 177, go for it. If I want to solve this one, which 2 colors am I adding together? Got it, fair enough. If you use purple on your sheet, I'd say purple too. Orange and red. Orange is HIT plus red is TIJ. Green is what they add up to. And I could solve from there. Once I solve, it says to find TIJ, so I would plug back in. Again, take a time. Final problem. T is in the interior of angle IJK. First thing you want to draw is the angle. Am I picky on where I put the points on that angle?
Yes.
Yes, specifically 1 point. Which point?
Okay.
We're just focusing on the angle first. I am picky on where I put B. You're not wrong. But in the name, if it's IJK, J is the middle. I and K go on the other sides. B is in the interior. I am picky that I put that one in the interior. And I draw my line through it. Now this one has a slight difference in how this problem's approached. So we are going to finish this one, but it's really not bad. Tells me the measure of angle IJK is 172. The upper one, the lower one, or the big one is IJK.
The big one.
The big one. J is in the middle, go towards I, go towards K, that's the big one. The measure of angle IJB is 78. J is the vertex, go towards I, go towards B, that's the upper one. Find the measure of angle BJK. J is the vertex, go towards B, go towards K. Do you notice it didn't tell me to put an expression in that one?
Because they want me to find it.
They want you to find it, but the other ones wanted us to find them too, and they put an expression there. The difference is, do you see a variable in this entire problem? There's letters, but is there variables? No, the letters are all points. There are some problems that aren't going to put variables there. You are welcome to say, this is the thing I'm looking for, I'm going to call it a variable. What variable do you want to use? Most people use X. If the problem doesn't have variables involved, you can put a variable into it and then make your equation. Which two things am I going to add together to make the full thing? Orange, blue, and red are my options. I just said blue. Wow. Orange, green, and red are my options. Which two am I adding together? Green and red. Green's 78, red's X. They're equal to orange, which is 172. Some of these problems are just meant to be simpler than others. I know this doesn't necessarily feel simpler for some people, but essentially, if I know this is 78 and I know the full thing is 72, could I have just subtracted them? Yeah, that's what this is essentially going for. Do I get 94?
Yep.
So the measure of BJK was equal to 94 degrees because X was BJK. So I didn't really have to do much to plug it back in. Okay, that's enough of me talking.